Um, but still, we have commercial systems, microprocessors, which are synchronous, right? So
Well, absolutely.
people are wondering, this asynchronous sounds so advantageous. Why aren't the commercial manufacturers embracing asynchronous design? Why are they still using synchronous logic?
Well, I mean, so there are a number of answers to that question, right? So I think in the microprocessor domain, there are the things that are slowing down microprocessors right now are things I would argue are things like the memory system. It's the organization of the microprocessor, right? So, and I mean, so because of that, I mean, that's sort of a fundamental thing that has nothing to do with whether it's asynchronous or not, right? I have to get memory from my memory data from my memory chip to my CPU, and if that's the limiter, that's going to stay the limiter, right? So today, I would argue that for something like mainstream microprocessors, there isn't a huge amount left to squeeze to improve the performance without doing something radically different, right? And industry doesn't like radically different, right? I mean, that which is why a startup company can even exist, right? So that's the challenge, especially given we have all this software installed base. It's not so easy to change. For good reason, industry doesn't like radical changes. I mean, there's a very good reason for that. Makes a lot of sense. I mean, if I would argue, the other thing is sort of asynchronous design. We really didn't know how to do a great job until not too long ago. So I mean, in the 80s, it was the first asynchronous microprocessor was designed in 1988, right? Which is, I don't know, depending on how you want to count, 20 years after sort of approximately the first synchronous microprocessor, right? Something in that order, right? And so when people were sort of, I think in the early stages where it would have been easy to show the advantage, the asynchronous design community wasn't ready. And today, I mean, there's not much left to improve, period. So, I mean, the amount of impact you can show in the microprocessor domain seems limited. Unless you look at it as a very different type of problem, like this, this low power application we looked at for sensing, right? That's a very different architecture. So unless you do something sort of substantially different, if I have to implement, an x86 chip, it's not going to be that much better. I might save some power, but as far as performance is concerned, you've hit diminishing returns a long time ago. We're being limited by lots of other things that are sort of system level problems and not sort of chip level, circuit level problems, I would argue.
So what do you think about the issue? Often people bring up the issue of tools, right? So there's, the companies have this very well developed synchronous tool set, and you guys have developed, a full tool chain for asynchronous design, but there would have to be a huge transition in terms of the design environment in order to
Yes,
move to
that's definitely the
asynchronous.
case.
And like I say, it is risky, and it's and taking these big risks is a little challenging.
Absolutely, and it's I mean one way I like to think about it is that sort of the synchronous design complexity, the sophistication of the chips you could build, and the design tools that were available sort of they grew up together, right? So the tools got better, the chips got better, the tools got better. I mean, there was this nice little virtuous cycle, if you like, that drove the whole industry, right? For actually almost 3 decades now. I don't know, depending on how you want to count, right? So it's been a while, and sort of the asynchronous folks weren't ready when this was happening, and so there's actually a big barrier to entry to write good tools. I mean, that said, I mean, a lot of the core techniques from a tool perspective aren't that different. But of course, the tools are no longer, sort of all the high quality tools now are produced by industry. And, so we're not in a world where the industry is open sourcing CAD tools. If we were actually, I could produce an asynchronous suite very quickly because I could just reuse a lot of the work they've already done. But in fact, there's a funny story for this. When at my company, we wanted to work with a commercial vendor to map designs to our asynchronous FPGA. And all we did was we basically gave them a new model for performance. We said, don't use what you're using right now to figure out how fast the chip is going to run. Use this other code instead. And it wasn't much code. And they could just plug that into their system and optimize for our chip. With everything else they had done for the synchronous world, just reused, right? So, as I said, if I could get a sort of we could get hooks into the commercial tools, I would easily be able to produce a good suite. But that is a barrier right now, and it's sort of a chicken and egg problem, right? A mainstream company isn't going to do this unless some important customer is going to tell them, we want this. The important customer is waiting for the demonstration to say, okay, we need to go in this direction. But to produce that demonstration, you need those tools. So there's this circular dependency, if you like, which was, of course, broken in the 80s in the synchronous domain because designs were small enough that a couple of people could sit down and do them by hand and do a good job, which then could bootstrap this process. But we can't do that anymore. And so that's part of why my group writes some tools, even though we don't write papers about them, or we have to do them to get our designs done. But it is an issue. I've talked to a number of companies, and the first thing they want to know is who should I buy the tools from? And you don't have an answer to that question. So that's a tough sell. And companies are the industry is doing okay, right? I mean, companies are making money, they're doing fine. And to compound risk on risk on risk, it's too much. I mean, from a management perspective, I can easily see somebody senior at the company saying, this is crazy, we shouldn't do this. There are too many unknowns, and with good reason, right? I mean, they're on a spec schedule.